Okay, here we use the compound interest amount formula given by this equation, that is A equals P times 1 plus R over N raised to the power of Nt, where A is the amount to reach and P is the initial amount or the amount invested. R refers to the rate of interest, and this has to be in decimals, and N is the number of times the amount is compounded per unit of time, and T is the time in terms of years or months. So let's plug in the information given over here. That is, the invested amount is 4,000. So I'm going to put P equals 4,000, and we will also replace this amount to reach, which is 6,000. So in place of A, I plug in 6,000, and this equals amount invested, that is P. I plug in 4,000, and this has to be multiplied with just to make this a little bit small to create some space, and this has to be multiplied with 1 plus R. R is 1.8%, but let's convert this to decimal. So 1.8%, and this equals 1.8 divided by 100. So this equals 0.018. So I put 0.018 for R divided by N, which basically tells you the number of times it is compounded per unit of time. It is compounded monthly. So in 1 year we have 12 months. So we have to put N equal to 12 and raised to the power of N, which is 12. And then we have to determine times. So we put T as the time. So now let's simplify, and we have to solve for T from this equation. We can divide both sides by 4,000. So I divide by 4,000 here, also by 4,000 here. So these 4,000 gets cancelled, and we can cancel these zeros like this, and so this reduces to 6 fourths, or we can say that this is 3 halves, because this is 3 times 2 is 6 and 2 times 2 is 4. So we get 3 halves, and so this equals 1 plus 0.018 divided by 2, 0.018 divided by 2, and this equals 0.0015, 0.0015, and this has to be raised to the power of 12t. So 3 by 2 equals 1.5, and this equals, when you add these two, we get 1.0015, and this is raised to the power of 12t. Now let's apply natural logarithm to both sides. So when we do that, we get natural logarithm of 1.5, and this equals natural logarithm of 1.0015 raised to the power of 12t. Now, using the power rule of natural logarithm, we can put this 12t in front of natural logarithm. So in the next step, I write this natural logarithm of 1.5 on the left side, and this equals 12t multiplied with natural logarithm of 1.0015. Now we can solve for t from this equation and rearrange for t. So therefore we see that t equals natural logarithm of 1.5, and this is divided by 12 times of natural logarithm of 1.0015. And we can plug this expression into the calculator, and when we do that, we approximately get the value of t as 22.5, and this is rounded to nearest tenth of the year. This is rounded to nearest tenth of a year, and so we see that it takes 22.5 years for the amount to reach $6,000. And so this answers this question.